All right, we're live. Welcome everyone. This is a IP&D webcast. I'm Anthony. I'm a coach at Udacity.
Sorry, I'm Jonah. I'm also a coach at Udacity.
So today we're going to be talking about structuring your code and planning out, basically planning out your code before you start on a new project. We had a question submitted before the webcast started. How do you tackle a new project? And basically, that's what this whole webcast will be about. So hopefully we'll be able to answer that question moving forward. I guess we can start. Jonah, what do you do when you have a new project and you're trying to scope out what you want to do?
Yeah, I mean, that's exactly what I want to do is scope it out. So you don't want to just dive in and start with a blank screen, start typing code. It's hard first, and then it's also frustrating because you'll type a little bit and then you'll wonder what should I do next. Whereas it's best to sort of approach it with a structural concept. So you'll sort of map out what you want your code to do, map sort of the inputs, the outputs, and then sort of think about what it's going to look like even before you write it. It's generally sort of what I do.
It's almost like writing a paper, writing an essay. You want to start out with an outline, some idea, some direction. And the biggest danger, as we'll see today, is that when you dive into code without an idea of structure beforehand, you may not get into a big situation immediately, but you might find that the code you write becomes difficult to maintain, difficult to follow. And we'll see some examples of some well-structured code and some not so well-structured code. So really closely tied to the idea of structure is this term that gets thrown around a lot called spaghetti code. And it kind of refers to, it is delicious, but not always with code is it delicious. Spaghetti code kind of refers to code that's overlapping. And kind of just getting tangled. And the original definition of it, I have some code on my computer that I'm going to share with everybody. So this is some code. I'll make it a little bit larger. So you may not recognize this programming language, but this is a programming language called BASIC. And basic in its syntax. You may be able to just look at this and be able to know what it does. So, Jonah, can you look at this and do you have any idea what it might be doing?
Yeah, sure. It kind of looks like you're defining I as the integer 0, and then you're defining it again as itself plus 1. So I equals 1 now. So you print I, which is 1. And then you have it print out 1 squared equals I times itself. And then if I is greater than 10, then you go to 60, but it's not. So we'll go next, and then we'll go to the next line. It says go to 20. So we'll go back up, and then we'll add 1 to I, print it, make it squared, and then print that, and then just keep doing it over and over until I is greater than 10.
Right. Yeah. Basically. So this is kind of it's a weird way to do this. You might already be thinking that there's a better way of doing this with what you already know about Python.
Yeah, it took me a little while to get through that. I get it, but it took a while. Yeah.
Right. Exactly. And that's the big problem here. So this, to show you that it does do exactly what Jonah does, there's a little website I found here called Run Basic. And Run Basic lets you run code written in BASIC. Cool. So let's paste in our BASIC code, and when we hit run, we'll see it prints out all the squares from 1 to 10. Cool. So you may be looking at this and you're wondering, what the hell is this go to statement here?
Yeah.
So this used to be a really, really common thing with programming languages. And in a way, you're still using it when you write Python. Okay. You just don't see it. So what's going on here, you might also see these numbers on the side.
Yeah.
In BASIC, one thing we can do is we can assign lines like an identifier.
Okay.
So in this case, we're just calling each line like 10, 20, 30, 40, sort of like you have the line numbers on Sublime here, but here these have like actual meaning to the computer.
Okay.
So like you said, we start out I equals 0, we change it to the value 1, we print out 1 equals squared, 1 squared equals, well, 1 times 1 is 1. We say if 1 is greater than or equal to 10, well, it's not, so we go to the next line. It says go to 20. And so what go to 20 says is go to line 20. And it comes back up here, and now 1 equals 1 plus 1. Well, now it's 2. Right. Print 2 squared equals 2 times 2. That's 4. And we go on. Then at some point we'll say, well, if when I is 10, we'll say if 10 greater than or equal to 10, well, that is true. Right. Then we'll go to 60, and 60 is this line program completed.
Okay.
And then this end statement is just something for basic when to terminate the code. So what does that almost sound like if you were to think about that idea in terms of like Python?
It seems like you could do this pretty similarly using like a while statement, like while I is less than 10, then you loop through something.
Right, totally.
Or like a for statement, you could do that too. I'm not sure exactly how that would pan out, but some sort of conditional loop.
Right. So basically, right, you're saying the key word there. It's a loop.
Yeah.
We're essentially just almost like artificially creating our own loop by like saying like go to this line and then keep going back to that line until a certain point.
Yeah.
So in Python and tons of other programming languages now, we have really useful things like for loops and while loops. So this is a code that does the exact same thing in Python. You see it's only 3 lines now, and this uses a for loop. So we're just saying for I in range 1 to 10, meaning for all the numbers between 1 and 10, print out I and its square. And then at the end, print program completed.
That's pretty familiar, yeah.
Yeah, so if I build this, we see we get the same result we got with run basic.
Yeah.
So in a way, on like the lowest level, because basically what happens when you write code in the computer, right? The computer doesn't actually know how to read Python, and that might be something that a lot of beginner students don't necessarily realize.
Right.
But what's happening is this Python code is being translated into something that the computer can read.
Right.
And in a way, what's happening is that there is a go-to underneath this for loop. And what that go-to is saying is that at the end of one iteration of the loop, go to the beginning of the loop. So it's sort of like it's built in. Now, why is this one referred to as poorly structured spaghetti code versus this one is considered nice and well-structured? I don't know. Do you have any ideas about why that might be?
I mean, I guess it's just a matter of like being easy to read. Like for the Python one, I can read it basically in plain English, and I can understand it. Whereas the other one it took me a minute to like read through it and understand it and like follow the lines to the end. I'd have to like basically run it in my head. Whereas this, I can just see it and understand it.
Right. Exactly. And that's exactly why we're not using the go-to statement anymore. This is a cleaner syntax. It's more easy to read. I can see the return to the loop immediately. It also is, quite frankly, really nice that we don't have go-to anymore because it's very easy to abuse that power. Go-to gives you a lot of power in being able to just like send your code to wherever you want within your program. But it's very easy to misuse that power. And so basically there's almost no way to do it now with a modern programming language. Although there is a joke module called GoTo that somebody developed as an April Fool's joke. And so this is what it would look like in Python, but we won't waste our time with that right now.
Okay.
So you may be wondering if GoTo is not a problem anymore in computer science because we have for loops and while loops and if statements and just a whole lot of better things. Right, exactly. Why I have to worry? Why do I have to care about structure if certain important parts of my code are structured for me? Right? Is there even such a thing as spaghetti code anymore?
Right.
And I guess in the strictest definition, there isn't.
Okay.
But spaghetti code now refers more broadly to just bad structure. So I have some examples of some poor structure, but before we jump into that, we'll actually talk about the problem more generally. So I don't know if you know this, but Jonah just opened up a store for this problem, and he ships items to places all over the world. He has all sorts of different customers. And since it's a pretty small store, they don't offer free shipping yet. But if you purchase the item and you live in the continental US, your shipping cost is $5. If you live abroad, if you live in any other country, your shipping cost is $10. And the same is true for people in Alaska and Hawaii, since that's really far away from the rest of the United States. Yeah. So we want to help Jonah write a code that tells him what the shipping cost will be for his customers. So the way I'm going to start out doing this is I have this drawing here, this diagram. And this kind of gives an idea of what we want to do. So we want to say if the country is the US, and there's a big black box here, and you'll see what's under that in a second. Okay. Just to start out, we'll say if it's in the US, then the shipping cost is $5. Okay. And if it's not, then the shipping cost is $10. That looks easy enough to do, right? Sure. Simple if statement, it's practically written right there for us. Mm-hmm. So let's add in, make sure that it's in the continental US before we set the shipping cost to $5. So, Jonah, what do you think we should do to, what do we do if it's not continental US?
Well, it's going to be the same as if it wasn't in the US, right? So the false would mean the shipping cost is $10.
Right. Okay. So, I mean, it seems pretty simple, right? And you might be tempted to say well, we've got shipping cost is $10 up here, and well, that just wants to go to the same place, so let's just have it point right back at there.
Yeah, that makes sense.
It seems to make sense. This diagram, I can read this, it makes a lot of sense to me. Right. What we'll actually find is that implementing it in this way, where you have essentially two branches, mm-hmm. this false here and this false up here, pointing to the same place, right. That's going to cause us a little bit of a problem. Really? And we'll see exactly what's going on there. So here's some code I wrote to do this. There's actually 2 examples. So this is define shipping costs. It takes in a country and a state. For just to make things easy, we're saying that if a country is anything other than the US, then its state is none. Okay. There doesn't exist one. Cool. So this if statement right here is a little convoluted. Jonah, do you have an idea of maybe what this is trying to say?
Yeah, I guess if the country is USA and the state is not Hawaii and not Alaska, so any state that's not Hawaii or Alaska, then this cost equals 5.
Right, exactly. So this very long, kind of difficult to read statement basically says if it's the continental US, then we'll set the cost equal to 5. Okay. And otherwise, we'll set the cost equal to 10. Okay. It seems to make sense, right? Yeah. Took a little effort to read that for sure. And if we run it, we have some test cases here, so we'll see what it is for California, Alaska, and Germany. Okay. And we'll get 5, 10, 10. So exactly what we expect. The code works. Cool. But maybe we could do a little better, make it a little easier to read. Sure. So going back to our diagram, generally you're going to get into issues if you have branches pointing to kind of the same spot.
Okay.
And that's exactly what we saw here. And you know, you can think of it in this way, right? So we basically have three different cases.
Right.
Right. We have the case where the country, or it's the continental U.S. We have the case where it's in the U.S. but it's Alaska or Hawaii, and we have the case where it's any other country. But we only have two end results, so these don't exactly match up. That makes the code harder to read. So a better way to do this might actually be, we'll straighten up the branch here, move our false down with it, and we'll make a third box and put it here. Okay. So you can see sort of how parallel the diagram looks now, right?
Okay. Yeah.
The diagram itself is a little easier to read. It's easier to digest for people who maybe aren't familiar with the problem. They can look at this and follow the diagram, and you'll see they'll be able to follow the code better. But it is, again, important to think about how you're structuring things. So there's actually another bad example doing exactly this that I have here. Well, it's not exactly a bad example. It's better than the last one, but we could do even better than this. So this one we're saying, so if the country is the US, and then we check if the state is not Hawaii and not Alaska, the cost is 5.
Right.
Otherwise, the cost is 10. Otherwise, the cost is 10. So what do you think is like kind of confusing about this one on first looking at it?
I guess I just don't really know where the else. Well, I guess I know where the else comes in. It just gets a little bit complex near like line 19. It's like if state is not Hawaii and not Alaska, and it's 5, but then the else is like if it is Hawaii or Alaska.
Right.
So I guess it's just a lot of like counter, what do we call this? Counter positive or something.
Right.
Some strange conditional statements going on. I mean, I get it because you explained everything to me.
But on first glance, it's harder.
It's on first glance, it's a little bit harder, yeah.
And probably the hardest thing about this is that you have these like this if statement within an if statement.
Yeah.
Sure. Not only that, but both if statements contain else clauses.
Yeah.
But also you have, first of all, 2 else clauses that are identical, right? But serving different purposes.
Yeah. That's true.
And they're also incredibly vague, right?
Right.
You know, if you spent some time with this code, you could figure it out. And granted, this is a very small case, so it might only take you a minute, 2 minutes to read and digest. But if you can think of this on a grander scheme, then
yeah, if you had like a huge shipping network and had to calculate like postage taxes, and it would look
exactly
crazy.
It would be terrible. It would look so ugly. So this also, while it satisfies our nice new diagram, it's not the best. And you know, if I run it, we see it works, but again, like you said, as your company grows, as your store grows, and you're starting to, you know, maybe decrease shipping costs, or maybe they're different in different countries, this can get out of hand pretty quickly.
Right.
So there's a better way, and basically this is what I came up with. There's probably a lot of different approaches. But looking at this, do you think you can explain to the students what you think is going on here?
Yeah, I mean, it looks pretty straightforward. Like you go through a bunch of these if statements. So if the country is not USA, then it's going to be 10. And then you check if it's Hawaii or Alaska, then if the state's Hawaii or Alaska, then it's going to be 10. And otherwise, it'll be 5. So basically, you're kind of narrowing it down from like the largest down to like the smallest.
Right, exactly.
Which is cool.
And that's a way that it seems almost counterintuitive, right? So I think a lot of people, when they first think about this problem, they want to make this first if statement if equal to USA, right? But you kind of want to start most generally and then like build down from there. So the most general shipping cost applies to those who don't live in the US, right? That's like the biggest group of cases, right? So essentially right. You're like breaking down the cases into smaller and smaller bits as you go along.
Cool.
And you can see in the structure of the code, it looks actually quite similar to our diagram here, right? Mm-hmm. So you have, like very parallel statements here. You don't have if statements nested inside each other. You don't have these confusing, vague else statements. You just have this one at the end here, which, like maybe there's something we can do to make this a little more clear. Mm-hmm. Maybe we can just put in a comment, or maybe we can write it a little differently. Mm-hmm. But this is a much better structure, and we can run it and see it does the exact same thing as the last two examples did too. Cool. Yeah. So there's one other type of spaghetti code that also comes up a lot too, and this one's been even more common in recent years than the ones we've been looking at here, and that's as it relates to object-oriented programming. Okay. And if you've gone through stage 3, you've dealt with some OOP before. It can get a little messy if you're not, thinking about what you're doing as you're going through, if you're not planning ahead. Mm. So for this problem, I'll be the subject of this. Okay. And what's going on here is I have a car, and I drive a car. My car is driven by me. I want to make some code that kind of shows that relationship, right? So basically, I have two classes here, one for cars and one for drivers. And in order to initialize a car, you need to know the model of the car, and you need to know who the driver is. Okay. We just initialize like we always do, and then we have a little function here that if you call this function, then what it will do is it will return you the name of the driver of the car. Okay, that makes sense. Sort of in parallel, we'll have a class for drivers as well. Drivers all have names, and they all have cars, otherwise they're not drivers. Right. Initialize like normally, and then we have a function called drives that tells you what car that driver drives. Gotcha. So down here I've got some initializing cases, and my car is a Kia Optima. Okay. So initially there's no driver, right? A car is built, it doesn't have a driver until someone purchases the car. Okay. So that's how we're going to initialize it. Part of that is because if we were to try to put something in here, well, there don't exist any instances of the class driver yet, so we have to just say none. Got you. But we can think of it as like when a car is manufactured, it doesn't have a driver yet. Okay. And then we have a variable for me. I have a name, Anthony. I just bought the Optima. So now I am tied. The car is listed on my class as mine. Mm-hmm. And now we'll just update the driver attribute of the Optima to be me. And then at the end, we'll have some print statements that use the functions we have. So if this is working as we want it to, we want to say Anthony drives an Optima, and the Optima is driven by Anthony.
Seems like it should make it work, yeah.
Yeah, so we'll build it, and that's exactly what we get. Cool. So I have another little graph here. So this is essentially what is going on here. Right. You have driver drives is dependent upon car, and car dot is driven by is dependent upon driver. And in a lot of ways, when you look at this code, it seems to make sense, right? Like, yeah. Cars have drivers, and drivers have cars. It seems to make sense that we build this relationship, right? Right.
Just we have a question real quick. Make sure that we can see the code.
Sure.
Because it was hidden by the Google logo before.
Okay.
So maybe make it a little bit bigger.
I can just go out of full screen and then.
Yeah, that works.
Is that better? Okay. Sorry about that. All right. So definitely looks like this seems to make logical sense, and in a lot of ways it does. Generally, you want to avoid this type of circular dependency. And that's what we call this going on here, a circular dependency.
Okay.
Can you think of any reasons why this might not be a great thing?
Maybe if you decide change one of them. If you want to get a new car, you would have to create a new object, but then you would also have to change the driver. But yeah, it's a little bit confusing about what would happen if you wanted to change one of those objects.
Exactly. So there's two things that people always say about circular dependencies, and that is that they're hard to test because in order for me to test anything about the car, it's tied very closely to drivers, so I can't test these classes independently of each other.
Gotcha.
It's also hard to maintain. That kind of goes into what you said.
Right.
If I want to change even like something about a car, it will probably involve a change to driver also. Now this can get really bad when you're working on a very large project, because large projects often involve multiple different files containing many different classes. And if you accidentally build in a circular dependency there, then you could be having to do lots of changes in lots of different places.
Okay.
And you're just going to make a huge headache for yourself.
So does that mean you can't make objects that contain other objects?
No, not at all. In fact, oftentimes it might make sense. And in this case, it sort of makes sense. What you want to do is focus instead, try to avoid circular dependencies and focus on like one-way dependencies. So I have a little bit of a refactor of this initial idea. And in this case, you'll see there's no isDrivenBy function here. We just have a drives function. And I could do this any way I want. Well, I'll talk through the code first, and then we can kind of analyze it. But we'll have an instance, the class car, all it takes in now is the model of the car. Whereas the driver still takes in a name and a car, and it still contains this drives function that tells you what car the driver drives. So now we can initialize Optima with just the model of that car, which is a lot simpler than the last time we tried to initialize it. And then we can initialize me with my name and the car that I drive. So when I run that, I see Anthony drives an Optima.
Nice.
And you may be wondering, well, we don't have the isDrivenBy function anymore. And that's true. We have lost that capability. But ultimately, this is easier to maintain, easier to test, easier to work with. So that trade-off is worthwhile for us.
Gotcha.
So what do you think is kind of better or even like worse about this code? I mean, just your initial observations.
I mean, it seems a lot sleeker. Like car has just one, variable associated with it, and that's the model. And driver has, one method and then two variables associated with it. So in terms of like the objects itself, it's a lot simpler. It's a lot easier to understand. And it also seems like you'll be able to one driver will be able to have multiple cars. Which I guess you could have done before, but I feel like it would have gotten pretty complex pretty quickly.
Might take some work to give this. I don't think it has the ability yet to take multiple cars. Not sure exactly. But definitely it's easier at least to give this code the ability to take in multiple cars.
Yeah, I guess you'd have to make a list or something.
You'd have to work this out so car could be a list, which might screw with the function, but still relatively small change compared to what we'd have to do with the last one. And it's this dependency here. We have driver depending on car in this case. I could have very easily done it the other way around. And that's the kind of thing about circular dependencies, is usually you have a choice of which direction you want the dependency to go. In this case, I chose this because I felt that drivers are only drivers with a car. If you have a driver without a car, then it's that person but a car can exist without a driver.
That's true.
So that's always possible. There's, I'm sure, an argument for
self-driving cars.
So that's true. Self-driving cars, and I'm sure there's an argument for the other way around, that cars need to exist with drivers. But basically, you can build in the dependency the way that makes the most sense for your problem, the way that makes the most sense to you.
Yeah.
Just try really hard to avoid those circular dependencies, and that's where kind of charting out and thinking about your problem and saying, what is it that I'm trying to figure out? In a way, the questions is driven by and drives are the same question, just reversed. So let's cut out some of the unnecessary verbiage and just simplify it.
Cool.
Yeah. So yeah, those are the examples I had. I don't know, do you have any other thoughts on code structure and the importance of it?
Not really. It seems like we went through most of it. It's cool how near the end it's sort of like a creative aspect to it, where you have to think about things not just in terms of like they're coding the way they work, but the way they work in real life.
Right.
And I think that objects are kind of a cool way of thinking about things in real life. Like when you do decide to make a database of all the trees in the world or something, like you want to think about things in terms of how they're organized in the real world.
Yeah, definitely.
It's cool how that translates into code.
For sure. That's one of the things that I think a lot of people, including myself, really love about coding, is that there's a huge creativity aspect to it.
Yeah.
And it's sort of like this. It's almost like an intersection between an art and a science, depending on what stage you're at and what you're doing, right? In a way, the initial things we were talking about with goto being the basis of the for loop, right? That's sort of like the science of how your for loop works.
Right.
But then when we go into why is a for loop preferred to a goto statement, that's more of an art. Effectively, they do the same thing. They might even do the same thing in the same amount of time, but we like the for loop. We call it often, the word computer scientists love to use is elegant. It's elegant code.
Yeah, right.
So it's elegant, it's simple, it's concise, and that's sort of one of the beauty parts of it. It's trying to determine that structure and trying to make it as elegant as possible.
Yeah.
And I guess one piece of advice that I heard, somebody wrote this online, that as I was researching this, is never adapt a language to fit your design, adapt your design to fit a language. I think that was pretty good advice. Sometimes you might find, and this happens a lot when I'm programming, is that you'll start on some code and it's structured a certain way, and then at some point in you're like, this isn't really that good. Maybe I should have done things differently. Screw it, I'm already halfway and I'm just going to keep going.
Yeah.
There's a real important step in becoming a programmer where you stop and redo things, right? And rethink about things.
Be mature, yeah.
And it can suck sometimes.
Yeah.
You might have written 100 lines of code and realize that you maybe should have structured things a little differently.
Yeah.
Ultimately, as we've seen and as we kind of discussed with the last example, the earlier you catch bad structure and the earlier you go to correct it, the easier it will be to maintain, the easier it will be to test, and it'll make your life a lot easier down the road.
For sure. That's
sort of the thing that planning helps with that. Another thing that helps with that is just being stuck in that situation and just saying, this is one of those things that Anthony talked about.
It's learned through experience, struggle through it.
Yeah.
I feel that. All
right, cool. Well, thanks for joining us.
Yeah. Hope to see you next time.
Yeah, definitely.
All right.
Have a good day, everyone.
Bye, guys.